A very pleasant day, future chemists. Welcome to the first ever episode of Spoleto's Pedagogical Chemistry Apparatus, where chemistry meets entertainment. I am your chem buddy, Karlene Jeciel, together with our other chemists, Rhian Inocencio, Leira Tulabot, Brian Corpuz, and Ram Primero, will assist you in paving a way towards an engaging learning experience in the field of chemistry.
I know you're familiar with our topic for today, for we will be discussing chemical reactions. Rest assured that this topic will be made interesting for you. Just sit back and enjoy.
First of all, what do we mean by chemical reaction? Chemical reaction is a conversion of one or more substances into one or more distinct compounds. In a chemical reaction, the atoms that make up the reactants are rearranged to form new substances, called products. Now, how are such terms associated with each other? Chemical reactions, substances, chemical elements, and compounds. Chemical reaction is the conversion of one or more substances, which are also called reactants, into one or more distinct compounds, which are subsequently called products. Take note that elements or compounds are under substances.
An example we have for today is colored flames. Colored fire isn't magic, it's science. It all boils down to the way different elements react when heated. Normally, when things burn, we see a yellow or orange flame. That's because the burning materials are emitting light at certain wavelengths we perceive as those colors. But when we add specific chemicals to the fuel, things get interesting. These chemicals contain metal atoms. When those atoms are heated up in the fire, they get excited and jump to higher energy levels. But they don't stay excited forever. When they fall back down to their normal energy levels, they release that extra energy as light. The color of the light emitted depends on the specific element. So, by adding different metal salts or compounds, we can influence the light the fire gives off, creating flames in various colors like blue, green, purple, and red.
Before we start discussing these colored flames, let's start with its components. After all, we need to comprehensively know how it boils down to how fire is produced. First of all, a chemical process known as combustion produces fire. When particles in it come into contact with oxygen, they accelerate at a very high speed. These particles can originate from fuel sources like wood or gas. The sensation of heat is added, and the touch releases energy in the form of light and heat-related images.
Second, the point here is there isn't actually a particular component of fire that interacts with substances. As a unit, they function as what is known as the fire triangle. This is made up of components like heat, oxygen, and fuel. Heat is what causes a fire to start in the first place and keeps it going. Anytime a flammable substance is fuel. Moreover, its moisture content, size, form, amount, and arrangement are evaluated to establish its strength and spread. When fuel burns, it reacts with oxygen in the nearby region to support the chemical process of fire.
Now that we've already discussed the chemical process involved in igniting a fire, let's talk about how a colored fire is ignited. Why or how does it change into a certain color? When a cation, or a positively charged ion, is exposed to flame, one of its electrons in the ground state, a state where an electron is at its lowest energy state, absorbs energy, moving to a higher energy level called an excited state, a state where electrons starts gaining energy. In this excited state, the electron gains energy. To return to its original state, the electron must release the same amount of energy it absorbed, emitting a photon of light. This released photon has energy equal to the transition energy and determines the color of the flame. The energy of the photon is directly related to its frequency, which is inversely related to the wavelength of light. Therefore, the color of the flame changes due to the light photons emitted during this process.
Now here's the fun part. Different chemicals produce different colors. To create pink flames, use lithium chloride. Wide and hygroscopic, lithium chloride is soluble in ether, alcohol, and water. It has a chemical formula, lithium chloride.
To create light green flames, use borax. As a salt of boric acid, borax is a naturally occurring mineral. It is sometimes referred to as disodium tetraborate, sodium borate, or sodium tetraborate.
To create orange flames, use sodium chloride. An ionic compound with a 1-to-1 ratio between the sodium and chloride ions is sodium chloride. Sodium chloride is commonly called table salt, common salt, and halide.
Below is a sample experimental video clip performed by the King of Random on YouTube. Come on, let's watch this together.
Moving on to green, every resource I could find recommended the same thing, boric acid, which is usually found as an ant and roach killing powder. Let's just try putting that in, adding some ethanol, and see what color it burns. Ooh, that is immediately green. Like no warm-up time with a blue flame or an orange flame. That went straight to green. No wonder everyone recommends this stuff. It's pretty conclusive. That's green. It looks like something straight out of Harry Potter.
And that marks the end of today's session. Got any questions? Leave a comment down below and we'll surely answer it. Or message our Facebook account, just look up SPCA Official. Thank you so much for listening. We hope to see you again.